Somewhere over the Florida Everglades, a helicopter moves slowly above the tree line. Below it, stretching for miles in every direction, is one of the most extraordinary ecosystems on Earth. A shallow, slow-moving river of grass, tangled with cypress stands and sawgrass prairies and dark water that goes nowhere fast. From the air, it looks peaceful, almost prehistoric. And in a way, that is exactly the problem. Because crawling through that water, hidden in that grass, coiled beneath those trees, is something the tea does not belong there. Something that has turned one of America's most treasured wild places into a silent, slow-motion catastrophe. And now, scientists are fighting back with a plan so strange, so counterintuitive, so almost absurd on its surface that most people, when they hear it for the first time, assume it must be a joke. They are loading dead mice with a common painkiller you probably have in your medicine cabinet right now, and they are dropping them from the sky by the millions. The target is the Burmese python, and the weapon is Tylenol. To understand how we arrived at this moment, at a point where the best scientific minds in American conservation are airdropping medicated rodents into a swamp, you have to go back to the beginning, not the beginning of the crisis, which is recent enough that people are still alive who watched it unfold in real time. You have to go back further than that. You have to go to Southeast Asia, to the dense jungles and warm river systems of countries like Myanmar, Thailand, Vietnam, and Indonesia, where the Burmese python is not a catastrophe. It is a native species. It plays a role. It has predators, competitors, parasites, and diseases that keep its numbers in balance. In its home ecosystem, the Burmese python is simply one piece of an ancient, complex, carefully calibrated natural machine. It eats. It gets eaten. The system holds. The Burmese python is one of the largest snakes in the world. Adults routinely reach 12 to 14 feet, the largest ever. Recorded in Florida, measured over 18 feet and weighed more than 100 pounds. They are ambush predators of extraordinary patience and efficiency, capable of lying motionless for days, waiting for prey to come within striking range. Their jaws can unhinge to swallow animals far larger than their own head. They are not venomous. They kill by constriction, wrapping their muscular bodies around prey and tightening with each exhale until the animal suffocates. They eat raccoons, opossums, bobcats, deer, herons, egrets, and, on occasion, alligators. They have been found with full-grown white-tailed deer inside them. And in the Everglades, they have essentially no natural enemies. Nothing hunts them, nothing keeps them in check. They are apex predators in a landscape that evolved without them. The question of how they got there is, in retrospect, a story about human carelessness on an almost incomprehensible scale. The exotic pet trade surged in the United States through the 1970s and especially the 1980s. Burmese pythons were popular. They were large and impressive, and when young, manageable enough to keep. Between 1975 and 2018, more than 180,000 Burmese pythons were imported into the United States through the live animal trade. Florida, with its warm subtropical climate and its culture of exotic. Pet ownership took in a substantial portion of them. Baby pythons were sold at pet shops and reptile expos across the state. People bought them, raised them, and then, inevitably, some of those people discovered that a snake that fits in your hand at 12 inches does not stay 12 inches long. It grows and grows. And when a 20-pound, 10-foot constrictor becomes too large to manage, too expensive to feed, and too dangerous to keep, some owners made a decision that would reverberate through the Everglades ecosystem for generations. They drove out to the swamp and let it go. Hurricane Andrew accelerated the process in August 1992, when it tore through South Florida as a Category 5 storm, destroying buildings and facilities that housed exotic animals, releasing snakes into the wild in unknown numbers. The warm, humid, prey-rich ecosystem of the Everglades turned out to be almost perfectly suited to a snake from the jungles and riverways of tropical Asia. The climate was right. The food was abundant. The terrain was vast, inaccessible, and impossible to police. And so the population grew, slowly at first, then faster. The pythons bred, their eggs hatched, the hatchlings survived at high rates because nothing was killing them. And by the time wildlife managers understood what was happening, the problem had already moved from manageable to something far more serious. The numbers, when you look at them directly, are genuinely difficult to process. Between 1997 and 2012, road surveys of the Everglades documented a 99.3% decrease in raccoon sightings. Opossums dropped by 98.9%. Bobcats fell by 87.5%. Marsh rabbits, cottontail rabbits, and foxes effectively disappeared from the survey data entirely. These are not small fluctuations in population. These are ecological collapses. A species that had lived in this ecosystem for thousands of years, that was woven into the food web as both predator and prey, was simply gone, vanished from areas where pythons had become established. In one study, researchers fitted adult marsh rabbits with radio transmitters and released them back into areas of the Everglades known to have python populations. Within 11 months, 77% of those rabbits were dead, and the vast majority of them had been killed by pythons, not by hawks, not by alligators, by pythons, an animal that had no business being there. The cascading effects of these mammal declines ripple upward and outward through the entire ecosystem in ways that scientists are still trying to fully understand. Mammals are not just prey. They are seed dispersers, soil aerators, and food sources for other predators. The Florida panther, one of the most endangered animals in North America, depends on white-tailed deer as its primary prey. As pythons consume deer, they compete directly with panthers for food. Raptors, red-tailed hawks, great horned owls, bald eagles depend on rabbits and small rodents. When those populations crash, the birds decline. The Everglades is not a collection of species living separately from one another. It is an interconnected web where everything touches everything else, and when a single thread is pulled hard enough, the whole fabric strains. Nobody knows exactly how many pythons are currently living in the Florida Everglades. That ambiguity itself is part of the problem. Estimates range from a lower bound of around 30,000 to potentially several hundred thousand. The difficulty of counting them reflects why managing them is so extraordinarily hard. A Burmese python lying in sawgrass does not want to be found. Its coloration, a pattern of brown blotches on a lighter background, provides near-perfect camouflage in the dappled light of the wetland. They move mostly at night. They can spend weeks motionless in a single spot. GPS telemetry studies that tracked tagged pythons revealed just how rarely even experienced researchers, actively searching for snakes in known locations, actually spot them. In one study, a team searching with dogs, with aerial support, and with knowledge of where a tagged snake was located, still failed to find it on the majority of visits. The Everglades is enormous, roughly 1.5 million acres. And a python can be invisible even when you are standing 5 feet away from it. Florida tried the obvious solutions. The state created a professional python removal program in 2017, paying a select group of hunters an hourly wage to track and kill snakes on state lands. The program has been expanded since then, and it has removed thousands of pythons. The Florida Python Challenge, an annual competitive event that invites the public to catch as many pythons as possible over a 10-day period, drew hundreds of participants and successfully removed nearly 300 snakes in its 2025 edition. The record holder walked away with $10,000 and 60 pythons. These programs matter. Every snake removed from the ecosystem prevents dozens of eggs from hatching. But the scale of the problem defeats even the most ambitious removal programs. Even if hunters removed 1,000 pythons a year, every year, for a decade, they would barely make a dent in a population that can number in the hundreds of thousands, reproducing at a rate of up to 100 eggs per female per year. You cannot hunt your way out of this problem. You cannot trap your way out either. Pythons are largely indifferent to conventional trapping methods. The terrain is too vast, the snakes too cryptic, the breeding rate too high. The math simply does not work. And so scientists began thinking differently. If you cannot find the pythons fast enough, and you cannot remove them one by one at a rate that matters, then you need something that can reach them where they live, distributed across the landscape, operating at a scale that no team of human hunters can match. You need something the python will come to, rather than something you have to bring to the python. You need bait. This is where acetaminophen enters the story, and where the tale takes a turn that is equal parts brilliant and deeply strange. Acetaminophen is the active ingredient in Tylenol. It is one of the most commonly used drugs in the world, sold over the counter in every pharmacy, taken by millions of people every year for headaches and fevers. It is safe for humans and for most mammals when taken at normal doses. But for certain reptile species, it is lethally toxic at very small doses. The reason comes down to biochemistry. When mammals ingest acetaminophen, their livers convert it using a metabolic pathway that neutralizes the drug. This is why a person can take 2 500 milligram Tylenol tablets and feel nothing worse than headache relief. But snakes lack the specific liver enzymes that mammals use to process acetaminophen safely. In a snake, the drug is metabolized into a compound that attacks the hemoglobin in its blood cells, converting functional hemoglobin into methemoglobin, a form that cannot carry oxygen. The snake's blood stops delivering oxygen to its tissues. It goes into a form of internal suffocation. Within 24 to 72 hours, the animal dies. The amount required to kill a snake is tiny. For the brown tree snake, a different invasive species that has devastated the island of Guam, researchers found that 80 milligrams of acetaminophen was sufficient to cause death. That is less than a quarter of a standard adult human pain relief tablet. For Burmese pythons, the lethal dose is higher, but still remarkably small relative to the size of the animal. Laboratory studies confirmed that juvenile pythons, given acetaminophen-laced mouse baits at doses of 80 milligrams, died at a rate exceeding 85%. At 100 milligrams, mortality was essentially complete. The proof of concept for using medicated mice as an invasive snake control tool actually came not from Florida, but from Guam, a small American island territory in the western Pacific that has been living with its own snake nightmare for decades. The brown tree snake arrived in Guam accidentally on military cargo ships shortly after World War II. Within a few decades, it had driven most of Guam's native bird species to extinction or to the edge of it. The island has no native land snakes, which meant its birds had evolved with no fear of predation from the ground or from ambush. They were defenseless. The snakes also caused rolling power blackouts by climbing electrical infrastructure and bit sleeping infants in their cribs. Guam was, by the 1980s, an ecological and public safety crisis driven entirely by one invasive reptile. The USDA Wildlife Services began experimenting with acetaminophen mouse baits for the brown tree snake in the early 2000s. They found that dead neonatal mice, tiny newborn mice, the right size to be swallowed by juvenile snakes, could be loaded with a small acetaminophen tablet and dropped from helicopters into the jungle canopy, where the tree-dwelling snakes would find and eat them. To keep the baited mice from hitting the ground, where they might be found by other animals, each mouse was fitted with a tiny cardboard streamer designed to catch on branches and keep the bait suspended in the canopy zone where the snakes live. The program worked. It killed snakes. It did not measurably harm the few native species that remained on Guam. And it established the principle that aerial delivery of acetaminophen-laced mice could function as a viable snake control tool. Florida is a much more complicated environment than Guam. The Everglades is not a simplified, species-depleted island ecosystem. Or at least, it is not supposed to be. It is, or was, one of the most biologically rich landscapes in North America. This means that any intervention introduced at scale carries real risks of harming non-target species. Birds, native reptiles, other mammals, any of them that consume a poisoned mouse or that consume an animal that has recently consumed a poisoned mouse could potentially be harmed. USDA researchers spent years investigating this. How do you maximize lethality to pythons while minimizing risk to everything else? How do you deliver the bait in a way that reduces the chance of a native animal getting to it first? How do you ensure that the dose in each mouse is consistent and sufficient? How do you make the dead mouse attractive enough to a python that has been sitting motionless in the grass for 2 weeks? Pythons, unlike the brown tree snake in Guam, are primarily ambush hunters rather than active scavengers. A significant concern was whether they would even eat a dead stationary mouse bait. Research showed, however, that Burmese pythons will consume dead prey. They are not exclusively live prey hunters. The key was ensuring the bait was presented in a way the snake would recognize as food. The scent profile of the mouse matters. The freshness matters. This size matters. Different sized baits for different sized snakes. Researchers looked at ways to make the bait more detectable to pythons, including using pheromone compounds that attract python chemoreception. Because pythons smell using their forked tongues, detecting chemical signals in their environment, a bait that is chemically attractive can draw a snake out of hiding from a significant distance. This is the hook that makes the program viable. The python does not need to be found. The python finds the bait. The scale of what is being proposed and tested for the Everglades is genuinely unprecedented in conservation history. Millions of medicated mice, distributed across hundreds of thousands of acres of wetland, delivered by helicopter or small aircraft, flying regular grid patterns over the landscape. It is logistically extraordinary. The mice have to be sourced, prepared, dosed, frozen for preservation, packed for aerial deployment, and deployed in a pattern calibrated to give each python in the treatment area a reasonable probability of encountering at least one bait. The program has to be repeated because pythons reproduce continuously and new juveniles are always entering the population. It is not a one-time treatment. It is a sustained campaign running for years or decades, gradually reducing the population through attrition. The environmental monitoring required is equally demanding. You cannot release millions of anything into a complex ecosystem without knowing what is happening to every element of that system. Non-target mortality has to be tracked. If native snakes are dying or native birds are eating the baits and suffering liver damage, the program has to be adjusted or stopped. Field teams monitoring the Everglades for secondary effects of the bait program represent as large a commitment of scientific resources as the airdrop itself. This is not a casual experiment. It is one of the most ambitious field-scale conservation interventions ever attempted in the United States. There's a profound irony at the center of this whole story, and it is worth sitting with for a moment. The Everglades is being poisoned, gently, strategically, with surgical intent, in order to save it. The scientists deploying these baits are introducing a chemical into an ecosystem that is already severely damaged, using a drug that kills in order to restore the conditions under which life can thrive. Every conservation principle in the textbook says you should add as little as possible to a stressed ecosystem. Interfere minimally, let natural processes reassert themselves. But natural processes cannot reassert themselves when there is a top predator present that evolution never anticipated. There is no natural check on the Burmese python in the Everglades. There is no native predator big enough and bold enough to take them regularly. There is no disease adapted to them. There is no parasite that controls their numbers. The ecosystem has no lever to pull. Humans introduced this animal, and so it falls to humans to remove it, and the only tools available are the ones that reach deep enough into that vast, impenetrable wilderness to matter. The situation in the Everglades is also not unique in kind, even if it is extreme in degree. Invasive species are one of the leading drivers of biodiversity loss worldwide. They are second only to habitat destruction in the number of extinctions they have caused. Islands are particularly vulnerable. Isolated ecosystems that evolved without certain predator types are catastrophically unprepared when those predators arrive. But continental ecosystems can be devastated too, when the invader is aggressive enough, adaptable enough, and arrives in a landscape that offers everything it needs. The Everglades offered the Burmese python everything: warmth, water, prey, cover, and no enemies. It was, for the python, paradise. For everything else, it was something much darker. What makes the Everglades case particularly heartbreaking is the baseline that was lost. Before the pythons established themselves, this was a landscape of extraordinary abundance. The mammal populations that have now been nearly eliminated were the backbone of the food web that sustained everything from the Florida panther to nesting raptors to wading birds, roseate spoonbills feeding in the shallows, white ibis moving through the cypress domes, wood storks circling above the sloughs. All of them depend, in one way or another, on the health of the mammal communities below them. When those communities collapse, the reverberations move upward. The birds decline. The panthers struggle. The system grows quieter and simpler and less alive, in ways that are easy to feel in the field, even when they are hard to quantify in a paper. The people who work in the Everglades, the biologists, the water managers, the python hunters, the conservation advocates, describe a landscape that has become eerily quiet in areas where the pythons have established themselves most densely. Drives along levee roads at night that used to guarantee raccoon and opossum sightings now yield nothing. Researchers who have been working in the system for 20 or 30 years talk about the silence as a kind of grief before and after that happened within their professional lifetimes and is still happening now. That context, that lived experience of watching a place change, is what drives the willingness to try something as radical as airdropping millions of medicated mice into a national park. When conventional approaches have failed and when the alternative is continued ecological collapse, unconventional begins to look reasonable. There is also a technological dimension to this fight that goes beyond the mice themselves. Python hunters have increasingly turned to tools like thermal imaging cameras, which can detect the body heat of a python against the cooler background of the swamp, even at night. Trained detection dogs have been deployed, animals capable of smelling a hidden python that no human eye could find. Genetic environmental sampling, or eDNA, allows researchers to detect whether pythons have recently passed through a water body by testing the water itself for shed DNA. Radiotelemetry, using implanted transmitters in Judas snakes, captured pythons that are released back into the wild to lead hunters to previously unknown aggregations, particularly during mating season, has become one of the most effective active removal tools in the program. In the breeding season, male pythons seek out females, and a radio-tagged male will travel to where the females are concentrated. Follow the tagged snake and you find the cluster. It works, but it is labor-intensive, expensive, and limited in geographic scale. The airdrop program represents a qualitative shift in the ambition of the intervention. It is the move from targeted removal to landscape-scale population suppression. The goal is not to catch every python. The goal is to push the mortality rate high enough and the reproductive success low enough that the population begins to shrink rather than grow. Population models for invasive species show that even modest increases in mortality can cause populations to decline if they are sustained over time. You do not need to kill every python. You need to kill enough, consistently enough, that births no longer outpace deaths. That is the threshold the mice program is designed to push through. Whether it will work at the scale the Everglades requires is a question that will take years of data to answer. The program being tested today is a pilot, a proof of concept in a defined area with intensive monitoring designed to show whether the basic approach is viable before committing to the full-scale deployment. Scientists are cautious. They acknowledge the challenges. The Everglades is not Guam. The terrain is more complex, the non-target species more numerous, the snake population more established, the area to be treated in orders of magnitude larger. There will be surprises. There will be adjustments. There will almost certainly be setbacks. But the alternative, continuing to manage the python problem through hunter programs that cannot scale while the population continues to grow and the mammal communities continue to decline, is not really an alternative at all. It is a concession. It is an acceptance that the Everglades will become permanently, irreversibly different from what it was. And the people who have spent their careers trying to preserve this place are not willing to accept that. Not yet. Not without trying everything. The mice falling from a helicopter over the river of grass are, in one sense, a desperate measure. A sign of how bad things have become, how comprehensively a human mistake, the casual release of a pet snake into the wrong ecosystem, can echo through decades and across millions of acres. But they are also, in another sense, a testament to something more hopeful. They are evidence of people refusing to give up. Scientists willing to try something that sounds absurd because the situation demands it. Conservationists who know that the Everglades they are fighting for no longer exists in the form they are trying to restore, but are fighting anyway, because the direction matters even when the destination is uncertain. Every python that dies from a medicated mouse bait is a python that will not lay a clutch of 100 eggs next spring. Every juvenile snake that encounters bait in the first year of its life is one that will not spend 20 years eating its way through what remains of the Everglades mammal population. The math is slow and the scale is immense, but the direction is right. And sometimes, in conservation, the direction is all you have. You hold it and you move forward. And you drop your mice from the sky and you count what comes back. And you keep going. The Everglades is worth keeping. That is the premise behind everything being done there. Not because it is pristine. It has not been pristine for a long time. Not because the work will be easy or cheap or guaranteed to succeed, but because what survives there, the birds, the water, the slow-moving pulse of life through the sawgrass, is irreplaceable in a way that is hard to articulate but easy to feel when you stand at the edge of it at dusk, listening to what is still there. Fighting for it with whatever tools you have is the only answer that makes sense. Even if those tools, for now, happen to be dead mice loaded with Tylenol falling through the Florida sky.